Good morning, student. Today, student, I will explain you the second part of refraction. In this, I will explain you the advanced numerical on refraction, and also I will explain you about the refraction through the glass slab. Student, can you see on the screen? I have drawn two figures. That straight line is the interface, student. That straight line is the interface, okay, student. And this is the object in the denser medium, and the person is looking from the above. So the person's position is in the normal. So in this case, student, I and R both are small. Okay, student. Second case, student, you see I and R both are not small. Means the person is observing not from the normal position above. He is observing little bit sidewise. Okay. So one case I and R are small. This is I and R are large. In the previous video, the formula which I have given, Hi upon Ho is equal to mu2 upon mu1, student. This formula is applicable only when I and R are small. Means the person is viewing the things from the above normal side, not from the sideways. That case, this formula is applicable. This is not applicable for lateral viewing, student. Okay. And student, remember what is Hi? It is the height of the image. Ho is the height of the object. And what is mu2, student? Mu2 is the light ray traveling in the second medium. The refractive index of that medium, student, is mu2, student. Now here, student, the glass slab figure I have drawn again. Glass slab, as you know, glass slab is a transparent substance made of glass. It is three dimension and its shape is cuboid, student. So one surface AB and parallel surface CD, I have given the name, student. You can see the incident ray, you can see the refracted ray, you can see the emergent ray, student. So that angle I have shown it in the figure. First, I have applied Snell's law, student, at the surface AB. And what is Snell's law, student? Mu1 sine theta 1 is equal to mu2 sine theta 2. What is mu1, student? Mu1 is refractive index of that medium where the light travels first. Mu2 is the refractive index of that medium where the light travels second. Theta 1, angle of incidence on the first medium. Theta 2, angle of incidence in the second medium. So now students, see the figure at the interface AB. Above it is air and below it is glass. I have applied Snell's law. So mu1, air, 1 it is. Angle I have written theta 1 sin I is equal to mu2, that is glass, mu g I have written. And angle R1, you can see it. Now student, I am applying the same formula at the interface CD. For CD, student, for the interface CD, the first medium is glass and second medium is air. So second means mu2 is for air. So that is why I have written 1 there into sin E. And mu1 I have written mu g into sin R2. Now student, if you compare the two equations, AB and CD surface, you will see sin I is equal to sin E. Here is the conclusion, student. Again you see I is equal to E. This means when a rays of light travels through a glass slab, okay, then the incident ray and the emergent ray, they are parallel. They are emerging out. The emergent ray is parallel to the incident ray. This I have written, student. And the light ray is laterally shifted, student. See the figure, laterally shifted. If the slab was not there, the ray would have passed straight. But laterally it got shifted. But it is parallel. So these 2 points related to glass slab we have to remember. I have done the mathematical proof. I have shown the mathematical proof also here, student. So 2 points which you have to remember. One, the ray passing through the glass slab, incident ray and the emergent ray are parallel. And the second, the light ray is laterally shifted, student, laterally shifted when passed through a glass slab. Now I will explain image formation by glass slab, student. See the figure, student. One ray I have taken straight passing through the glass slab. O is the object, student. O is the object. Second ray, as you can see, first time the refraction is taking place at the left surface. Okay, it is traveling from air to glass, so it is bending towards the normal. Now student, second refraction, second taking place again from glass to air. Ultimately the ray is emerging out. Now student, you must remember how to get the image. Trace the ray backside, backward. I have traced by shown by dotted row. One ray is straight, the center one, and the dotted one, they are meeting at I. Here student, I is the image. Remember student, I is the image of the point object O. So there are two refractions which are taking place student. And O is the object, I is the image. One more thing you see student, that distance I have shown OI, that is known as shift. Means the object has been shifted student. The object has been shifted. Now student, I will solve one numerical related to this. These are the data I have taken student. Mu I have taken glass 2 here, and the slab, thickness of the slab I have taken, that also I have taken 2 student. Now student, the object is at O at a distance of 5 centimeter from AB. See student, from AB at a distance of 5 centimeters student. See the figure. Now I have applied the formula student. Hi upon ho, mu 2 upon mu 1. What is hi student? Height of image. Ho is the object height. That is 5 student. Can you see it from the figure? Mu 2. Mu 2 is the light travels in the second medium. Their refractive index. It is already given 2. And mu 1 you know air. So I applied I got 10. So student, this 10, remember this 10 is the distance from the surface AB. This 10 is the distance from the surface AB student. Okay. This is the image for the first surface. Now I will solve it for the second surface student, CD. How I will solve this? This surface AB, I have named it as event number 1 student. Event, okay student? Two events are taking place, means two refractions. Now second event student, which is taking place at CD. One more thing remember student. The image of the first surface will act as a object for the second surface. This you remember student. For second, again I have applied the formula Hi upon Ho. Now student, what is Ho? See here the figure. I got 10 for the image of the first, and that is object for the second. So from student surface CD, see the figure, how much is the distance? 10 plus 2, 12. And this image is the object for the second surface. And that is why in case of place of Ho, I have written 10 plus 2 student. Mu 2 student, mu 2 is the second medium in this case, and second medium in this case is air. I have written 1. Mu 1 is the glass student for the second surface. I have written 2, and I solved Hi. Again student, try to understand what is this 6. This 6 is the distance from the surface CD student, CD. Okay student, CD. So from the surface CD, the final image I is formed. It is at distance 6. So from the surface AB, how much it is student? You can see it. From O to AB it is 5. From CD to I it is 6. So from the surface AB, this distance will be student how much? 6 minus 2, 4. So this means for the final, the object was at O 5 centimeter and the image is formed at I. Image is formed at I. Now how much is the shift student? This I have calculated here. You see it. 5 minus 6 minus 2. Got now student how I got 6 minus 2? See again I am explaining it. 6 is the distance from CD that I have written. 6 is the distance from the CD. Okay student. I require OI. Now the thickness of the slab is 2. So this means the distance of surface AB from I is how much student? 6 minus 2, 4. Okay. This means I is at distance 4 from AB and O is at distance 5 from AB. So how much is the shift in the image? 5 minus 4, 1 centimeter student. That I have calculated here student. Okay. So I have taken it as a two event. First at AB, one refraction. Second at CD, one refraction. There is also a shortcut formula student for the competitive exam. This I will show you in the next slide student. See here student, I have solved that numerical by another method student. How to solve student? See. This formula student. Formula you see. Shift T is the thickness into 1 minus mu surrounding. Means the medium which is surrounding the slab, that mu upon mu slab. Okay student. So T is given 2 in that question you have seen. Mu air is 1, mu slab is 2 given. So student, see the direct answer I am getting. See student, 1 centimeter. Directly I am getting. But remember student, this formula is applicable only when the surrounding medium should be same on both the side. Surrounding medium should be same on both the side. See student, next numerical. I have taken surrounding medium to be water student. See the next figure. Water. Glass 3 by 2 refractive index I have taken, and water I have taken 1 by 3. So I calculated the formula directly. Shift T into 1 minus mu surrounding and mu slab. Mu surrounding is how much? Water, which is 4 by 3. Mu slab is 3 by 2. I have solved it. I got the direct answer. Shift 0.22 centimeters student. The shift is 0.22. Means from O, if you shift towards the right side student, this shift is positive sign. Positive sign means it will be shifted along the direction in which rays are traveling. So here the ray is traveling in the right side student. That small dot, now that is I student. I have drawn it student. So remember student, when the shift is towards the positive, positive means the shift is towards the direction of the light student. Now I will show you the question. Another question student, see here. See student. Here mu I have taken 3. Outer means surrounding I have taken 3. And the rear medium, the slab I have taken 1 student. Okay, then again I have applied the formula. Means in this case student, in this case the light is traveling from denser to rarer. Denser to rarer student. The slab is rarer medium in this case. I have taken an example. Now see student, how much I am getting? I shift see minus. Here is the clue student. What is the meaning of -4? -4 means the image is left hand side of O, or you can understand the image is shifted in the opposite direction of the ray of travel of light. Image is shifted to the opposite direction of the ray of travel of light. In this example, light is traveling from the object toward the right side student, and the shift is negative. So the shift is in the negative side of O, left side of O student, that is 4 centimeter. So in this the image is shifted behind O student. So this is the case student, when the light is traveling from denser to rarer, remember the image is shifted towards the opposite side of O student. Means it is far away, the image becomes far away in this case student. So this point you should remember. Shift positive means shift is to the direction of propagation of light. And what is this shift? Image shift student. Object is at one place. That object will appear to be shifted, and that is image when you look through the glass slab. So two kinds of shift. One is positive, means it will shift towards the direction of travel of light. And there is negative student. It will shift to the opposite direction of propagation of the light. Just now I have shown student by the negative sign student. Now student, here is the another problem. I will solve it for you. See student, the above numerical. Here T is 4 thickness, mu is 2, mu 1, mu 3. But remember one thing student, here the surrounding is not the same. This means directly we cannot apply that shift formula. This you can solve it by the event method. I have shown in the first numerical. Event 1, left surface. Event 2, second surface. The image of first becomes object of the second. By that method you solve this question student. Okay, event 1, event 2, and you will get the answer. Directly you cannot apply the formula in this case student. Now let's see student another question. Three glass slabs are there connected together, mu 2, mu 3, mu 4. Okay student, surrounding is air and the object is at O. So first I have given the shift S1 for the first slab and I have applied the formula. See student, T1 minus mu surrounding mu slab. So first slab I have written the data student. Mu surrounding is 1, mu slab it is given here, see student, 2. So that formula I have written, I have applied. Shift came out to be 1 centimeter student. Now student, for the second slab, mu is 3. Again I applied the same formula student. Similarly third slab mu is 4, I applied the same formula. But student, here is one confusion. Because just now before I told you, if the surroundings are different you cannot apply the formula. But here I am applying it. But see student, the clue hidden here. Since it is a combination of the slab, you just assume that between the two slab some air is there, thin layer of air is inserted between the two slab. Just imagine it student. On that basis the surrounding becomes same, and when the surrounding is same you can apply the formula. And student, when now you apply the formula direct, Now you add all the shift, you will get the answer. So this is the shortcut method, student. If this kind of questions are there, where there are 3 slabs or more slabs like this, you can apply directly this formula. But remember this assumption, don't write it in the copy. This assumption, this is imagination, okay student. Since the answer comes out to be correct, so you can solve it, student. So today, student, I have given you clue for some advanced numerical on refraction. This is very interesting, student. As you know, today the age is of competition. So that is why you should not study only the given question on the NCRT. First, you should complete NCRT and then you go for advanced. And I am trying my best, student, to go to take you to the advanced level, student. Because NCRT question maximum student can solve on their own. It is the solution is also given in many places. Okay, student. If student any doubt regarding this video, you can ask it by calling me. We'll continue, student. Thank you.